Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this workshop brought to you by AWS and Tigera. My name is Cody, and I'd like to welcome you back to Techstrong Learning. We've got an exciting program ahead, but first, I do have just a couple of housekeeping notes that I'd like to review with you. First, today's session is being recorded. So if you'd like to follow along at a later point in time, perhaps you have to leave early, you will be receiving an email with a link to access this recording on demand. If you'd like to engage with us today, there are a couple of ways that you can do so. The first and easiest way is to use that chat tab on the right side of your screen. So I'd like you to go ahead and test that out for us by letting us know from where in the world you are joining us. I know we have a global audience and we want to see where everyone is from. Now, if you do have any specific questions, we do request that you send those questions to that Q&A tab on the right side of the chat feature. Sending your questions into Q&A just helps us keep organized and ensure that we can get to as many of your questions as we can. So please send in your questions early and often. And of course, before we close out today, we will be giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our conversation. So our workshop title is Securing Containers and Kubernetes with AWS and Calico. And I'm joined by Dheeraj Sehgal, Director or Technical Marketing Engineer at Tigera, and Gokul Srinivasan, Partner Solution Architect at AWS. So Dheeraj and Gokul, I really appreciate both of you joining me today on Techstrong Learning. Dheeraj, would you like to go ahead and take it from here?
Sure. Thank you so much. Thank you, Cody, for introducing us. Thanks for hosting us on Techstrong webinar. And thanks to all the participants who are joining us today for this webinar on securing containers and Kubernetes with Amazon AWS, which includes the EKS also and the Calico. So with me, I have today the partner solution architect who is subject matter expert on the EKS and the security side of the world. Gokul, would you like to start?
Sure. Thank you, Dheeraj. Hi, everyone. I'm Gokul Srinivasan. As a partner solution architect supporting the AWS global startups. And in today's, let's begin with an overview about what the Amazon EKS ecosystem looks like and what are the some of the best practices when it comes to securing the containers and the Kubernetes ecosystem. So before we get on to the security aspects, let's begin with the observability for security. And in the context of observability, AWS sees observability across 3 different towers. The first one is around the logging, where from each and every application and infrastructure perspective, a timestamped event gets logged, and the logging essentially becomes the foundation to cohesively create the observability stack. And followed by that, we have the traces. The traces helps navigate through a particular user. It could be a systematic user or an application user's navigation on the activities across the application stack. And the third component is essentially the metrics. So now we have the log information, we are tracing these details. And metrics essentially helps us define the KPI, a numerical data interpretation of the logs and the traces. And through metrics is essentially how the monitoring of the application and the infrastructure comes into existence. And collectively, this is where the overall observability for an application looks like. And specifically, this is a lot more important in the context of containers and Kubernetes. And the main reason behind this is, unlike any other application, setting up a container ecosystem and implementing an application and operating it within the container or the Kubernetes setup, more specifically the EKS, by itself is a pretty challenging task. And on top of that, enabling all this observability to provide the secured mechanism for operation adds up to the additional layers of complexity. And this is essentially where the observability of the containers and the Kubernetes ecosystem in the context of security becomes far more important. And with this lens, we will go deeper into what exactly the Kubernetes and the container security operations looks like in the Amazon EKS ecosystem. And with that, let's look into the fundamental of the Kubernetes setup. So within AWS, we have customers across all sizes, a small enterprise to a large enterprise that really spans across multiple geographies. And all these enterprises have both custom code solution from third-party ISV vendors, as well as homegrown applications that are running in the Kubernetes ecosystem. So the fundamental question they all begin with is, hey, how exactly should I select my Kubernetes cluster? What are all the components that needs to get into the Kubernetes cluster selection? And we see this from 4 different lenses or 4 different perspectives. The first one is the segment them by the various different application environments that is needed for your enterprise application. So rather than bundling multiple applications or multiple environments into the same cluster, segregate them based on the environments like a development, a QA, and a production. So this gives an initial level of isolation. And secondary, what we have seen across enterprises, a division of these environments based on the cost center. So most of these applications are owned by a specific department or a team. And the cluster really contains all the applications that's owned and managed by that specific team. So this gives a very clear identification and isolation from a cost center perspective. And the third aspect, essentially when it comes to larger operation, most enterprises begin with small scale Kubernetes application. And as they are growing their footprint, they increase the size of the cluster by adding more and more nodes. And this essentially creates a manageability issue. So the sizing of the cluster and the volume of applications that's running within the cluster poses additional risk in the form of it increases the attack surface. And it also creates maintainability issues. So with this kind of comes in the split failure scenarios. So under that circumstance, the enterprise split and create multiple clusters for the ease of maintenance. And finally, from a real-time operations and integration into a DevOps pipeline perspective, these enterprises create a blue-green type of deployment as they mature with their DevOps pipeline and the CI/CD integration. And that creates a final level of cluster classification. So based on these 4 categories, the enterprises split and design their cluster implementation. And this becomes important in the context of security, because now as the enterprise operates in multiple clusters, there is more need for these clusters to communicate with each other, and operational simplification, both at the application, the cluster, and at the network level for these pods that are running within this Kubernetes cluster to safely and securely communicate with each other, at the same time not adding up any additional bottleneck from an implementation and operation perspective. So with that, let's begin with the fundamentals. So before we operate the application in the Kubernetes ecosystem, every application development team begin by building a container layer, a container application. And each of the container image as part of the development comprises of multiple layers, and each of these layers adds up to a reasonable amount of security risk. Why? It is primarily because not all these layers are homegrown, where the application engineers and the DevOps team have a good understanding about the constituent components of those different layers. And most of the time, these layers are comprised of third-party libraries and third-party applications. So the first step that comes in as part of the container security is to ensure that the images that are being deployed in the containers are does not have any vulnerabilities, and they are safe in order to be promoted through the DevOps pipeline. And as part of that, some of the fundamental or the foundational thing that we would like to emphasize is eliminate the inclusion of unnecessary packages and ensure that only the bare minimal packages are included in these container layers. And then have these images built as smaller images with bare minimal tools that are really required for the container operation, rather than bundling all the required application libraries and integrations as part of a single container image. And most importantly, create separate process for the container build and the container runtime. So this way, any of the challenges, any of the tools that are required for the container build are not packaged and made available in the container runtime. So this ensures that the attack surface is kept to the minimal and operational efficiency are appropriately included. And avoid the inclusion of the root users. So always have a service-specific user and clearly define what the privileges of that particular user are going to be. And this is very important because all the attacks begins at the pod level. So if there is a malicious actor that gets access to the specific pod, and if that pod has a root actor access type of privileges, it becomes easier for the malicious actor to gain access to the pod, thereby getting into the root user system, and also sometimes getting into the kubelet libraries, thereby getting access to the cluster via the kube API. So that's essentially how we have seen the attack surface propagate, all beginning with the pod level access. So always begin with the principle of zero privilege and the zero trust policy. So the container images have the bare minimal privileges, are built using the fundamentally necessary components, and perform a round of vulnerability scan as you are building up the application. And this scanning essentially gets integrated as part of the CI/CD pipeline when you build the container image. And then secondary aspect is push these container images into a container registry once the build is complete. And that's essentially where the Amazon ECR or Elastic Container Registry comes in. So once the image is uploaded into the container registry, perform a secondary level of scan. And the main reason for having two different level of scan is to ensure that there is a thorough validation and the vulnerabilities are identified. And also these vulnerabilities get introduced on a regular basis, and there is a repository that gets maintained. So the container image might be built today, and the deployment might be happening in one of the environment a month from now. And between this period, there might be new vulnerabilities identified. So it's always a best practice to have the vulnerability scan performed during the build as well as prior to the deployment. So that's way you are minimizing the amount of risk caused by these vulnerabilities. And once the container image is built and is ready for deployment, that's essentially where the operational challenges begin. As now the container is going to be operating in a Kubernetes cluster. And at this juncture, you need to be careful about four major aspects. Essentially, these are the access patterns, the patterns in which the pods are invoked, executed, and operated by other entities. So we will look into these access patterns from a four major perspectives. The first is essentially the external traffic that comes into the pods. And these external traffic are essentially traffic that originates outside the cluster. And that traffic might be originating from within the VPC where the cluster is operating, or might be outside the VPC but within the same AWS account. Or this traffic might be originating totally outside the AWS ecosystem from the internet, an on-premise, or another cloud, could be anywhere outside the AWS ecosystem. So this external traffic should have the the right level of permissions and have an API gateway type of capability to ensure that the external traffic is having the required permission to access the respective pods. It is validated and it is authorized and authenticated as part of the overall application processing logic. The second aspect is the user access to the cluster. And this is essentially where we have users, which could be a systematic user or an application user, trying to access the cluster. And at this level, the Kubernetes ensures that there is a right authentication and the authorization mechanism are performed. It could be integrating with an IAM, an identity access management provider, or could be an Active Directory to ensure that the user start with the zero trust policy and only the authorized user are having access to the respective pods and the respective nodes. And now, once the application processing begins, the pod as such is not going to be performing all the necessary activities. And within the Amazon EKS, what we have provisioned is the Amazon EKS natively integrates with a wide array of AWS services. It's not going to operate by itself. And these could be AWS services in the context of observability, like the Amazon CloudWatch or the Amazon X-Ray, or it could be in the context of an application processing. The pod might be invoking a DynamoDB for a key value pair storage, or might be accessing the Amazon RDS for the persistent SQL data storage, or it could even invoke other application that's running in an Amazon Lambda or in an EC2 instances. So now the pod should have the necessary level of permissions to invoke the other AWS services using the principles that have been assigned to the pod. And finally comes in the pod-to-pod communication, where the pods within the cluster should be able to communicate with the pods within another pod within the same cluster, where the network traffic does not go outside the cluster, but all contained within the Kubernetes cluster. As you could see across all these four different patterns, there is a lot of communication that goes in, and these communications are totally outside the control and configuration of the respective pods. And this is essentially where the network level security and the network level permission becomes so very important, so that there is an isolation in the way the pods are packaged, the pods are operating, and the way the pods can communicate with each other. So we will look into what essentially those networking policies and the network level control comes into. And before that, let's begin with what exactly the network policy looks like at a high level. So in this example, we are just using a cat and dog example. We have a web application that is exposed to that is exposed outside the cluster. Could be an internet facing application or an intranet facing application that has a front end component. And this front end component essentially wants to access a cat pod, and the cat pod in turn can access the dog pod. So to begin with, there are 4 different layers of the network control that comes into play. One, begin with deny all, where there is no permission at all. Then comes in like deny all the ingress, deny all the egress, or allow all the ingress or allow all the egress. Or could be a combination of all these different traffic policies. In this example, we will see that the pod that we are going to target is the cat pod. So it begins with, hey, all the access to the cat pod is denied by default. And then we create an ingress network policy role that allows the access from the front-end pod. And this way, the front-end pod can access the cat pod. And the front-end pod, even though the cat and the dog pods are running within the same node, within the same cluster, when the front-end pod tries to access the dog pod, it will not have the necessary access. That is all defined by this network policy. And this is where the Kubernetes network policy provides the necessary level of control and also the observability with regard to the pods that operates within the cluster. And many of the customers that we work with are not operating within a single cluster. As we saw towards the beginning of this webinar, there are different clusters that the enterprise employs depending upon their workload, their cost center, and a variety of operational needs. And a good network policy should be able to support the network level traffic and the controls, just not within a cluster, but across a multi-cluster, a multi-account ecosystem. And the network policies are essentially what defines how the pods communicate with each other, such as other entities. In this example, we saw how the front-end pod can communicate with the cats and the dog pod. But in many times, in practical scenarios, these pods need to communicate with other namespaces, other network clusters, and also with other IPs, where the IPs may be running in Kubernetes or outside the Kubernetes. So the pod should be having a very good network policy that begins with a zero trust, principles of least privilege, almost like no privilege, and have a very clear identification about which of those applications have the right egress and the ingress level controls from a networking perspective. And all these controls happens outside the pod configuration. So this way you are able to segregate the build level permissions as well as an operational level permission, and should be able to support the ingress and egress, default by deny all, but also provide a variety of other combination. And in all this context, you need to add a network policy provider in order to use the network policies. And that's essentially where AWS partners like Calico come in place, who provide all the capability, just not at the network level, but across the overall Kubernetes management, providing the security as well as the observability for the end-to-end operation and maintenance of a multi-account, a multi-cluster Kubernetes ecosystem, which is very much in demand across all the AWS customers. So with that, I would hand it over to Dheeraj for us to learn more about Calico and the capabilities and how exactly the customers are benefiting using the Calico platform.
Thank you. Thank you so much, Gokul. And definitely, I like the cat dogs scenario here for sure. So just to continue on the thought of what Gokul basically mentioned right now, when we are looking at the Amazon EKS side of the world and the access pattern for any workload or containerized workload which is running within Amazon EKS, the access pattern, as said, are like external traffic to those pods, user to cluster, then pod to AWS service, which is basically inside out, and then inter cluster itself, like pod to pod communication. So when you focus very much towards the EK side of the world or running Kubernetes in AWS EC2, what you start to see is the first generation of container security, or I would say container network security uh, solutions basically start to fall short, right? And the reason it is going to fall short is not because they they cannot do it or anything like that, but it's more to do with the way they have been built. Is they have built more towards the traditional perimeter style of security, right? And in the case of Kubernetes, as we know, the abstraction of the infrastructure from the application is so strong that you need a totally a new way of doing that security and network policy. So when we start to see is like as Kubernetes can spread across multi-cloud environment, right? And you have the AWS as one of the main ones there. The entire coverage area with respect to the attack which can happen in an environment increases, right? And for any perimeter based firewall, that basically becomes a very challenging task to basically do and work with every type of container running in every type of service in every cloud provider. The next one, what we start to see is many times detection has been the more focus b- towards the security aspect of the story. As an attack happen, or as the attack is happening, we will detect it with some probes or something, and then we will alert the team, right? And that has been another approach, right? With this attack surface which you have, detection can basically be a second step rather than the first step. So that is where another piece we have started to see towards the Amazon EKS. And the last one is as all these pods and workloads are running in a different environment and they have the ephemeral, there is limited but visibility into the vulnerabilities and the security gaps, right? That gap can be like, okay, if I'm making sure uh, dogs are talking to cats or cats and dogs are not talking to each other, how can I make sure that every time the spot is spun up, that policy is followed, right? That remains there, right? And then if there is associated policy that cats and dogs are going to remain in one pool and they cannot talk to other animals within the zoo, that type of platform centric approach, that is another security gap, right? So how do you basically bring that multi-layer defense in this story, right? So what it does is it creates a situation for the security and DevOps people who are basically managing, running, and securing the EKS cluster and the workloads in it, uh, to have a gap in the response strategy, right? Because the coverage of the entire attack surface area takes time. So there is a gap in the response. Detention centric approach, because it creates so much of alerts, it overburdens the DevOps and the security team, right? That's a situation we run into. And the last one, because of the limited visibility, most of the critical application or business application you are running a regulated workload in your Kubernetes environment, your risk of being non-compliant, which can basically bring a pause to your business, which is not good, if you ask me. So in that case, let's see what happens, right? What type of attacks which people basically face with respect to their entire food chain of the Amazon EKS, right? Gokul talked about the ECR side of the world, right? Like code security, making sure the images are clean, and then deploying and then going into the runtime, right? When we look at this diagram, this is generally what we have seen is that during build time, the DevOps, the security engineers, the developers are looking at the threats in container images, right? They are looking for the vulnerabilities in the images. They are trying to compare it with respect to any type of CVE which is out there and its CVSS score, which they are trying to compare, and then putting it according to what is their tolerance level, right? Risk tolerance level. Then you have the deployment side of the world, right? Where Kubernetes is the orchestrator engine, and it has now become your super admin to basically take over, like where to spin a pod, where to tear it down, right? Which rules to apply, right? So in that case, your Kubernetes needs to be secured, right? Your kube admin server, your kube APIs have to be secure. You cannot have misconfiguration in your environment that if anyone takes over this deployment mechanism, they can spin up unnecessary type of workloads and containers, which they are doing for crypto mining or whatever it is, or they are changing some configuration to hold you hostage of running your application. From there, the main story comes is what we are seeing increasingly now is towards the runtime, right? There are vulnerabilities and malware which are running in the workloads during the runtime itself, right? What you're looking at is if your workload is talking externally to some type of service, that service is clean of any type of malware out there, which basically you can see it in the MISP database. And as the access of this distributed application within the cluster and outside the cluster is very important and a lot, what you're looking at is a command control type of communication threat, right? Data exfiltration threat, which can happen. Anyone can connect to your one of the service which is exposed and then take over it. And then from there, they can take out all the data. What you need is that you will not allow everyone to talk to your cluster and then block who you don't want your service to talk, but it should be other way around. The zero trust concept that my service knows it is going to talk to these or 3 or 4 external clusters or external APIs, and that's where it is going to go, right? And that's where it is going to talk, nothing to anyone else. The next one is the threat from the unauthorized resources. This is more the inside out operation. So what we look at is many of our customers, our users have a lot of data on premises. They have it available in their traditional environment, right? Oracle database or any type of MySQL, Postgres, or whatever. And that is basically behind a traditional firewall. So when you're looking at the traditional firewall, which is IP-based firewalls, what they are looking for is like, okay, if I'm going to talk to a Kubernetes-based application, I will have to open up the entire set of IP range for all the cluster because there is no IP which is going to be constant here, right? Like you will always have changing IPs because that's how Kubernetes is. That makes a lot of the network security administrators very uncomfortable because now what you have done is any type of threat which has come into this cluster, Kubernetes cluster, will have access to this database and then they can just take over it, right? They can steal the data. So what you're looking for is a situation where you can have one IP, build a policy on it, and that IP makes sure that it is talking to the correct service within or microservice within your Kubernetes cluster. From there, the new ones which have come out are the unknown type of threats, right? The zero-day threats. Like it was always there, something was incorrectly built, incorrectly coded, and what it has done is now a bad actor is able to find a way into your system. So how do you basically protect yourself against the zero-day threats, right? So if you look at all of them, you have build time issues with vulnerabilities, you have deploy time due to the misconfiguration, then in runtime you have the container-based threats and the network-based threats all in play, and you have to protect your system or solution against it, right? So with Tigera, what we do is we basically help you uh, take a three-prong approach rather than doing detection. What we start to say is that if you bring prevention and risk mitigation, not mediation, risk remediation, but mitigation. So if you bring prevention and mitigation with detection, that will work wonders for your entire application, right? With prevention, what you'll be able to do is you'll be able to reduce the attack surface of your application. The diagram which I showed in the first one, if at all the endpoints you're able to, when you're deploying an application, you're able to prevent an attack there, that will basically make you have a strong security posture. The next one is like protecting workloads from runtime, known and zero-day threats, right? It is more to do with is like not just I'm looking at the host-based problems, like which generally the container security solutions used to do, but more to do with as my application is now talking to multiple services outside, right? And I'm building an application which is going to talk in a distributed manner to the external resources, internal to different pods, right? There is going to be a lot of communication. I have to make sure during runtime I'm protected from the network and the container-based threats. And there are known threats, network threats, right? There are known like IP threat feeds. That's what we get, right? So we basically get those. We have the MISP one, the container one, but also protect us against the unknown threats in network and container aspect, right? And the last one is as soon as the problem is seen, the security and DevOps team don't have to go and then stop everything they are doing and reprioritize and then try to fix issues. What they should be able to do is quarantine that workload or a container, put it in a safe zone or a like no access zone, and then let the entire application run. So the mitigation is more important so that it gives a breathing room to the security and the DevOps teams to fix the problem and then keep going for the business as usual. So how does Calico do it, right? So what Calico does is, with respect to reducing the attack surface to prevent breaches, we provide you with the image assurance, right? So as you have your container images in your Amazon environment, we provide you with the CLI-based scanner, which you can use to basically scan those images and then prevent their deployment into your life cycle, right? Then with the configuration one, as I talked about, or the deploy time, we provide you with a Kubernetes security posture management, which basically detects and remediates, in our case, with Kubernetes and their misconfiguration, right? The next one, which I talked about, the prevention, which is important, we provide you with the workload access control. These are the zero trust workload access controls. So what we believe is the concept you have picked up in ZTNA side of the world, that basically applies here also. Default deny, my application when it is deployed, because Kubernetes is open communication, in our case, we basically flip it other way around, that you are not talking to anyone, but then selectively you are making sure that you are going to talk to all these applications as you want, or the services you want to talk to, right? The next one is microsegmentation. This is more to do with isolating the workloads, right? Gokul brought up earlier on with respect to how the clusters are deployed, different organizations and everything. And that is what we have started to see in the namespaces, because many times having cluster for each organization has become really cost heavy. So people are looking at using just one cluster of EKS and then doing namespace based isolation. So with Calico, as soon as you deploy Calico, we look into the entire profile of your communication happening between workloads based on the namespaces, and then we automatically generate security policies to prevent namespace isolation, or I will say create namespace isolation, so that you don't have to worry about like, okay, I have to go to every microservice out there or every workload out there and build a policy on top of it, right? So you get another layer of security. The next one is application layer, right? So not only at the layer 3, layer 4, but what you're looking at is the HTTP level, the FTP level, and all that. You are able to get controls to protect against application layer attacks. The next one I talked about was the protecting the workloads at runtime from known and unknown threats, right? So with us, what you can do is you can get the container anomaly detection also, right? So what we are able to do here is we are able to detect a suspicious container activity. For this, we use the eBPF probes. So what we go in, and then every container which is running in your environment, we have built the detectors which are looking at your syscalls, which are looking at your the file system access. It's looking at the process info, and based on that data collection, we first baseline what is your normal operation or normal behavior, and then as any deviation happens, we basically start to make an alert. First, we basically map it to the MITRE framework, and then we give you the alert. And all this works out of box, right? So it is plug and play. So you don't need to write any custom open source files or type of scripts to basically get the runtime security for container-based threats going, right? It is already there. We are monitoring it, we are mapping it, and we are alerting you. From there, we have the non-network anomaly detection. So as I said, network and container threats should be equally looked and equally gracefully addressed. So in our case of network, we are looking at your workload communication, the latency, the spike, the packet transfer, the number of connections, and everything you can say. And then we baseline it. After baselining it, we basically are looking at it how to fix it further, right? Like if there is any anomaly, then we basically go and check it out. The next one is the WAF concept has been there. It has worked well for the applications. We are taking that concept itself at the workload level. So every uh, service or a workload which you want to enable or disable, you can have a WAF, web application firewall, enabled on it, right? So it will be the custom rules you can build, or you can use the OWASP 10 based rules. Another one is DDoS protection. So we do it there. What we have seen in the Kubernetes side of the world, like if there is a lot of attack which is going on, you will start to see a lot of increase in usage of your Kubernetes environment, which is auto scaling to basically meet the demand as it thinks, but it's an attack which is going on. So we can do the uh, the like the detection of an attack which is happening there out of box, because we have this anomaly detection, network anomaly detection happening, and we are looking at 5 or 6 parameters, and then we provide you with the alert, and then you can basically fix it. With the malware detection, we are basically using eBPF Proof to look at any uh, file hash which is matches the MISP database, and before it is loaded into the memory for its execution, we alert you that there is a bad file hash, and then you can go in and then basically act on it. The last one is mitigating the risk of exposure. We are looking at is dynamic service and threat graph, which is basically graph-based visualization. It is not the traditional monitoring trend analysis, but it's more about a map, right? That how each workload is talking to each other, what are its upstream, downstream dependencies, what are the security policies which have been applied, what are the gaps there, and what are the alerts, right? The next one is security policy recommendation. As we are looking at your environment all the time, we are basically looking at how to basically make sure that we generate automatic policies for you so that you can go and provide it or deploy it, right? The last one is the contextual alerts. So in our case, you don't need to collect data from different data silos in your environment on Kubernetes and then stitch it to make it sense. In our case, when you see the flow log, as I will show you in my environment, you'll be able to get through it and able to uh, like have all the information stretched, right? Like what is the IP address, what is the source name, what is the Kubernetes name address, what's the process, what's the socket ID, and everything like that. So all that is pre-populated. Before I go to the next slide, there are 2 questions. Does KSPM process give the user the option of doing they want to change the config? Yes. So when we basically generate a report, we basically tell you exactly where the problem is and then how you fix that problem. So that basically happens. The next one is if I have an already configured app armor, will this provide say how to better configure? No, so we don't do consultancy or anything like that for an existing tool. What you will do is you will basically come in and then you will connect your cluster to Calico Cloud, the EKS cluster or the AWS cluster. You will see the visualization on it. You will configure your compliance requirements, the thresholds which you have of pass and fail, and that's pretty much it. And that will generate the going on it. Kindly comment on pod quarantine. Awesome. Yeah. So the pod quarantine here means is following. As you have uh, a pod which has been infected. I love this discussion, by the way. This is good. Yeah. So as you can see here, this red pod is already infected, right? And what I'm worried about is like, okay, this threat is going to move into other pods which are within that node or across other nodes, right? So that propagation. So with us, what you can do is you can build a security policy through Calico Cloud as I go into the environment, and you can literally say is no communication allowed, right? So there is no egress out of this pod, and you can just shut it down. So that is the quarantine which happens one way. The second way, what we have seen is people go in and then use um, like honeypots. We have a concept of honeypots within our environment. So you can have a very lookalike service which is running, which is an empty pod, right? But exactly looks like your service which is running. Ideally, there is no communication which should happen, right? If it's secure, But if a hacker is able to connect it, he'll be able to connect it into the honeypot. You'll be able to trap that person there, right, or the bad actor, and then also do deep packet inspection with respect to like what type of information they're trying to get, where it is coming from, and then propagate it out. I hope that answers the question. Okay. Okay. So this is the one way. So the last one I showed was more of a DevOps way of thinking about the things, right? This is more from the security perspective, right? When we are looking at the security perspective, um, I was asking, does this make me know how to better? Yes, that's what it will do. So it will go through your entire EKS environment, and then it will provide you with an Excel sheet. I'll show you the compliance report, and then where you can see download the CSV. It will tell you like, okay, where the EKS configuration is not right or something like that, and then you can go and fix that. Yeah. So when I'm looking at this slide, this is more from a security perspective, right? As the security people are getting more and more involved in this, like securing the Kubernetes cluster or the containers running in these clusters, they are basically looking at from their point of view, right? Like there is a step one of reconnaissance, like someone is trying to figure out how or what is the pattern on this application, right? And then they are looking at is like, how do I plant my seed in there? And then from planting the seed on step 3, they're trying to spread it and then move the data out, right? So when you're looking from that angle, Calico basically provides the complete coverage, right? So if you're running EKS, you're running your workloads, you are standardizing on it, and you have put in uh, the guard duty and everything of Amazon on the cluster level. You have everything up and running. You have the firewall configured, but somehow the person is able to get into the workload, right? They are able to establish that connection. We basically come into that play. So our story basically starts as that when you have done everything which is needed on the AWS side with respect to the node level and the cluster level, now as you have gone further and your application or services are talking at granular level to the outside world, on the pod level, how do we basically start to make your life easier, right? So in reconnaissance, what we do is we provide you with the vulnerability management, right? We basically have a CLI based scanner. It basically goes through, looks into all the images which are going to go in, and then it will make sure to block any image which is deemed risky or fail, right? So you will have a threshold defined for it, and that's how it goes. We provide you with a workload based IDS and IPS, right? So intrusion detection and prevention, we basically look and monitor connections from bad actors based on not only inward but any custom thread feed, so open source or your own proprietary thread feed. So you can insert them, you can put them there. We look into all the IPs, we'll basically let you know, and then for domain names also we'll let you know. And then the anomaly detection, as I said, we basically look for any type of suspicious traffic within the cluster, and then alert you based on it. On the delivery and exploitation, like if a person has been able to connect here and then you are looking, the person is now trying to land themselves there, we do the malware detection at runtime. As I said, before it goes into the execution, we'll provide you the alert that this is a bad file hash which has been detected, stop it. The next one is the deep packet inspection. How does the system determine if traffic is suspicious? Okay, so I'll talk about this one in a few minutes. I'll show you in the platform itself. Uh, so workload-centric WAF, we detect the top OWASP, top 10, and other attacks for it, and from there it goes. Okay. Source type of, yes, that is going to be the case of source type of traffic, commands, and all that stuff, right? So the next one is the installation and spread, right? When you're looking at the installation spread, what we are looking at is making sure that you get the identity over microsegmentation, right? The regulated workloads are in one place, the other workloads are in a different place. We provide you with a security policy recommendation, and then we have policy tiering. I think so. This is one of the big things with respect to anything you do for Kubernetes. Security team has their own base requirements. Like you cannot talk to some uh, like banned IPs, right? Which can be geographical based or whatever it is, what you want to call. Security team will have their own layer of defense. then the platform team is looking like no one other than these four people or these four services can talk to the my Kubernetes cluster, right? Because I'm managing so many of applications on top of it, right? So you can build a tier on that one. And then as an application developer or DevOps person, you're looking at my specific service, like a payment service can only talk to a shopping cart service, right? And that's pretty much it. So I'll build that policy. And none of this policy will override each other. It will basically be built on top of each other. So it gives you a sense of different depth of defense there. And the last one is providing you with the access controls. Does this really mean related by? Yes, it gives you that also. Cool. Okay, so let me now shift into the environment itself because I think so I've talked quite a bit. Let me show you all this what I have talked about. Mhm. View tab, this one. Okay, yeah. So what you see here is when you come in, what we basically provide you with the cluster, as I talked about, was you just go into the connect the cluster. We give you Tiger Labs so that you can play with it, but you have a demo cluster which I built in the morning. So when we are looking at manage cluster, what you do is you basically come in, you connect your cluster, you give it a name, test, then you take Amazon EKS, and I basically, I can't do this. Yeah. So you basically go in and then connect, right? So you take this kubectl command, you paste it in your environment, and that's pretty much it. What you will start to get is a cluster, right, which is connected here. You will have the entire installation script available to you, like how it connected, what happened, what are the resources which have been deployed, has it been successful, not successful, everything like that, right? So you will have the entire installation history available to you here. Okay. From here, as I talked about, let's go through the vulnerability management, the first part, right? So when I go here, uh, this is the instructions. Okay, this is fine. This is done. This is done. Continue. Okay. So what you start to get is the image assurance piece, right? Some of the people who basically right way want into the runtime side of the world, what we tell them is you can go into the observability, you can visualize your environment. The first thing you do is this. So what you can see now is that, as I said, I have a graph-based visualization available for my entire application which has been installed. So I have a boutique application which is being run, right? There are common services to it. I can literally click on it and then go into the service itself. So upstream, downstream, all the dependencies are available. So I will know the posture of this application. Is it safe, not safe? I will get all the information with respect to any type of uh, policies which are being put in here, right? It can talk to this one, it can talk to this one, that type of stuff, right? And then I get all the information with respect to the insights. Let me do further. So as you can see is as I go through the boutique web, I can view like the alerts. So if there is a problem, it will start to show up all type of alerts here, and that's how it will go. You'll have the HTTP also. So some of the stuff which basic stuff which service mesh people require as they go through the stuff. Okay. So this is the IDS IPS, but we basically provide you with this visualization. So IDS IPS, it's simply going into so no here threat defense. Sorry. So threat fields. So this is IDS IPS. We have the Alienware threat fields. You can enable, disable. You want to do whatever you want to do. You can add your feed into it. You can add domain DNS based IP set. You can put a label that very specific. If there is a workload which has a label named as regulated, it will always have this IP threat feed going on, and that's how you basically build it out. Okay. Anomaly detection, simple. So as you brought up for the anomaly detection, and one of the gentlemen is also asking like what type of IDs you check, right? What we have is quite a bit of what you can say stuff we are looking at. Bytes in, bytes out, domain generation algorithms, DNS latency, generic DNS, application layer, HTTP, all this. So what we don't do is like, okay, looking at any spike, we will close everything. Over the time, what we are going to do is we are going to look at your application behavior. Let's say every Friday you run a sale on your website, which basically spikes up our traffic. That is a normal behavior, and our solution will look for that, right? And we'll baseline it. But let's say if the same thing happened on Tuesday and you have not done anything different, then that is an anomaly. And that's where we will basically start to alert you, right? And those alerts will show up on the dynamic service graph also, but they will also show up here, right? It will be a global alert, as I said, DNS problems happening, right? Suspicious traffic, snort rule. So we do the DPI, as I said. So you'll start to get all this and the honeypot I talked about, right? So this is how you basically start to detect stuff, right? Same thing for the malware detection. I don't have it enabled here, but you can see it available on this side. So WAF side of the world, simply what we do is we go in here, you configure your application firewall. I don't think so. What you do is I have all my services available here, the card service. I just need to enable it and just run this command, and it will basically enable the WAF just on that service. So you start to get that type of granularity for your service and the namespace. The micro segmentation, the main one which we talk about, right? The policies, right? So here what you can see is security team has its own area, platform has its own application and the default, right? So as I have built all this tiers, I can literally go in and then say, okay, what type of policy I want, right? So developer will have a policy based on this. Platform guy is just focused on the Kubernetes side of the world, and they have their own policies and the security. So recommendation policy, as I talked about, we have the recommendation policy available here. You can base it on the namespace. And then let's do ours. Okay. Yeah, because now it will recommend some policy. Okay. So what you can start to see is there is a policy which we have built, like, okay, this service should only talk to another service, and this should be ingress or egress policy. So you can build the egress also on this one. Further, as soon as you see the policy, it does not mean that you deploy it, right? What you can do is you will preview it. You want to see its effect on your entire system, right? Like what is happening with it, which type of communication it can broke, or what type of workloads it will affect, and all that information will get populated, right? And then you stage it. Again, you can see or have a visualization of it. And what it will start to show up here is as a stage policy. I don't think so I have done it here, but you will start to get a stage policy, and then you deploy. So it's not just creating the policy, it's about like understand the impact of the policy. Where does the policy live? So the way to read this policy board is these supersede everyone. So your security team can have a policy which says no one on this cluster or this platform itself can talk to specific like competitive website or malicious like countries which are banned, right? That type of stuff. So you basically stop there. Then you have the platform guys, right? So this will always get executed, and then platform guy will come into play, and then application, right? So one thing what you can see here is on this one, let me go here, the service graph. So when I go to the service graph for the visualization piece, I can literally see how does the policy work. So as I checked, all the contextual data is available to you here. You don't need to do any traditional monitoring stretching. All this information is available about their start time, end time, source IP, source namespace, like all that stuff, right? Source label, destination IP, time label, everything is available. And the policies I said, right? So 0 means the start, right? The first year. So what you can see the policy happened is into the application for this service, again to this service, this is allowed, right? So this is the only thing which will ever work, right? For that like secure communication, nothing else will work. Otherwise, you will see the change in the policy here. So we can try another policy. Let's see. Let's try this one. Yeah, what you can see is there is a profile. Only the Kubernetes common services will talk to that service on the Kubernetes side of the world, right? Then, as you're looking at this alerts, like we give you the HTTP DNS ones, like all this is available. You can literally go in and start a packet capture on one of the namespace, right? If the problem is there, initiate a packet capture. You put a name on that packet capture. I can pick up the namespace. I have the start time. So the thing is, if you see an anomaly happening at night and you are not available, you can put a name, time, start time, end time, particularly on that namespace. Pick up a protocol. You can add a port to it if you want to, and then just schedule it to run. It will basically run at that time, and then it will give you the information. Further, this information is only available to the person who is assigned to this service. It's not that everyone can come in and look at it, right? So that's further up there. Okay, so yes, you can absolutely do that. Going through a lot of, can I group the alerts and display those alerts? Yes. So in our system, what you can do is we have further Kibana integrated into our system. So with the Kibana dashboard, we have given you specific, where is it? Oh, so 1 second. Dashboard. Yeah, so you can get the specific dashboard you're looking for, right? I have a application layer dashboard here itself. I have a DNS dashboard. So all this data is already created, connected with you, so you will exactly know like how many requests, where it is coming from, what are the domain names, and all that stuff. So that basically starts to make available to you. Okay. Okay. Do we require specific level for? Yes. You can specify specific labels for the pods, and that will be automatically picked up by us here itself. So you don't need to worry about that piece. Yeah, so that is there. That's pretty much I have for my on the Calico side. Let me see if I am showing the slides. Okay, yeah. Anything else or anything, Gokul, you would like to add?
Nothing specific, Dheeraj. Just wanted to reiterate as a summary, right? While the AKS and the AWS native services provides the security on the infrastructure of the site, the application side of the world, how the application communicates with each other, that's an app. AWS really provides the flexibility for the customer. It's up to the customers to really determine what sort of applications they deploy and how their application should communicate with each other. And that's exactly where the Calico platform comes in play, to really ensure. So it's just not like a either or, it's the combination of the infrastructure level security provided by AWS and then the application level security that's fully managed at the Calico enterprise level. So wanted to reiterate as to how both the services fits. It's not an either or option. It's like a and option at both the infrastructure and at the application level, providing the 360-degree view of security, both at the application, network, and the infrastructure level for the overall operations and administration of these containers and pods.
Got it. Thank you. So one thing I wanted to say was the following, as we are going through it, that Calico with Amazon EKS provides you the entire uh, uh, active security solution for your containers and EKS, right? We basically provide you with the start of security posture management. Here, what it means is like as you're going and deploying these applications, you want to start with like what is your frame of reference, right? What's your reference point? In that case, out of box, you start to get the image scanning, you get the Kubernetes security posture management, you get the micro segmentation. There are the policy controls, DNS-based or IP-based, whichever you want. You have the application layer policies. So you basically have a set security posture. From there, as you're looking into the runtime side of the world, like you have the runtime security controls for known threats, as I said, right? The threats which basically you can stop, right? You can prevent, right? Or you can mitigate, right? So that is basically around the IDS, IPS, workload centric, WAF is there, DDoS protection is there, malware detection is. Then the next one is things which are unknown, right? Which can happen. In that case, we are doing the anomaly detection on the container-based threats and also on the network-based threats with our eBPF probes. And then we basically provide you alerts so that you can put mitigation into the play, right? And for mitigation, the dynamic service graph, as I talked about, contextual alerts, honeypots, and forensic. You can do troubleshooting with dynamic packet capture, and then you can quarantine the workloads. So that's how it is looking at. When you're looking at some things which I will say are going to be beneficial, I will highly recommend to basically sign up for Tigera, not Tigera, but AWS Dev Days workshops, which we run on, I will say, every on regular basis. Can you see my screen? Okay. Share this tab instead. Okay, I'm doing it. So what you can see is every week we are running in conjunction with AWS team a workshop, and it can be vulnerability management. It can be detecting and blocking the container network-based threats. It can be on the compliance piece of the world. So, and it's in EMEA and North America both. So you can basically come in. We have an upcoming workshop on the EKS blueprint, which is going to happen on 20th. So you can join us there. So there are some recordings also available. So you can do that, or you can go in and then this browser is an issue. So you can go into this tutorials itself, which are basically tailored towards the Amazon side of the world or other players. And then you can just do a self-paced workshop on micro-segmentation, observability troubleshooting, right? Or compliance or container security. You just need to get started. And that's pretty much it. Provide the information to the self-paced, good to go. Okay, let me go back, share this tab, or I can slides. Okay, that's pretty much it. Thank you so much. Appreciate it. And if you have any questions, let us know. Cody, are you back?
I sure am. So, Daraj, it looks like you did a really good job of covering a lot of the questions throughout the program as they came in. But there is one question that's been hanging out in the Q&A section. I'm not sure if you addressed it, but this participant asks, can you explain how Calico enforces network security policies within a Kubernetes cluster running on AWS?
Yeah. So the way we do it is like it does not depend upon the CNI, right? We basically work with AWS VPC CNI. So if you have any type of CNI, that's fine. What we have is the Calico policy engine. So that Calico policy engine is deployed as a part of your Kubernetes deployment, right? And then it is basically running as a daemon set on each of your nodes. And that's how we basically go in and deploy the policies out there. So we work through the management plane, but we don't touch your control or data plane. So we just go from that side of the world. Okay. There is this question on what is the relation between network policy and identity-aware microsegmentation. Perfect question. So the relationship between network policies and identity-aware microsegmentation is, as you know, microsegmentation came from the world of network, right? The point here was like, okay, I can give these silos of networking, and then only those type of VMs or pods will remain there, and that's pretty much it. In the case of Kubernetes, what has happened is now the microsegmentation moves upwards, right? It basically is not just tied to the IP, it is basically tied to your type of label you have, right? What type of namespace you are running in, right? What type of um, layer 7 protocols you're using, right? The service name you have, right? So all that basically makes it a very unique identity. In our case, what we do is our network policy, because we are embedded in your platform itself, we are able to see all these identities associated with that workload, as I mentioned, right? Like when you saw it in the here itself, right? So what we can do here is we can see every type of like associated information on your service, right? And when we can see that information, we basically are able to do microsegmentation based on it, right? So that's where the network policy comes into the play. So now you can go in and then build a policy for that application or that service itself, right? This service in this namespace will be allowed, right? This is stage, right? So you can build it, you can have your policy label selector, you can add more, and that's pretty much it. So this is how it works. Okay. Mm-hmm. Any other question, Cody?
So Daraj, just looking at the threat landscape, looking into the next half of this year, is there anything that maybe stands out to you as something that maybe we need to keep an eye out for?
Yeah, so I will say in that case, the teams have to watch out for two trends. One is, as more and more of you are going to use EKS, we are seeing explosive growth in adoption of EKS. People are moving away from managing Kubernetes by themselves. And I think so AWS has done a superb job with respect to making that experience like just pain-free, not painless, but pain-free. What has happened there is now more applications or more services are being put into the EKS side of the world. All the security guardrails are being put with respect to the EKS available security features or AWS security services. What is being left open, or it will remain open for a time, will be the workload side of the game, right? As you're using EKS, you have these workloads running in it. People are going to look for security at that level, one. And that is happening, by the way. It's not they are going to, it's happening, it's accelerating because of one of the reasons. Like a simple example I'll give is one of our customers runs their SaaS application in EKS. They basically have made a platform in which they do loan validation and origination for car dealers, like very specific that market. And more of these car dealers, as they are using these SaaS application and SaaS platform, as they move towards the Kubernetes, when they experimented, it was fine. But now they have started to move their regulated workloads into this EKS environment. That's where the world starts to change for them. And they are basically now looking at the workload level security. And that's where we come into play with EKS, because EKS took away their focus from managing the Kubernetes environment or keeping it like compliant or running. Now all the time is free to basically look into the container side of the world or the runtime side of the world. And as this application is talking to all these US auto dealers, and it's in the back end talking to some website provider, right? Or it is talking to some payment provider or some service maintenance, right? There are so many applications which are sold by an auto dealer. They are looking at us like, okay, all this communication which Google brought out, right, outside, inside, between these applications, they need it to be secure. And that's where they are looking at prevention, detection, and mitigation. What they are looking in prevention is my maintenance service needs to just talk to whatever one service which is running in their master application. It does not need access to everything. And from that one application or one connection, they should be able to do everything. So those type of things, they're looking at it, right? So they are building the WAF on top of it. They're putting IDS, IPS on top of it, right? That's how it is. As they're building the application, they're using the image scanner, right? So to make sure that the images which they want to use, they can use, and that's pretty much they go with. So the main thing here is, as you move your applications into the EKS, be aware of runtime security challenges for your workloads. And that's where go with something which is grounds up, build with that one, and is a part of your EKS environment. That is what Calico is. It's a part of your EKS as you deploy it.
Awesome. Well, Diraj, thank you so much for that. Gokul, I'm going to pose a similar question to you, but less looking at the future. But what kind of things are you seeing right now in your day-to-day that are maybe the top threats or something that our audience maybe needs to keep top of mind?
There are two things I would like to highlight as I conversate with my customers, right? One, an increased amount of the ransomware and the cyber security attacks that these organizations are subjected to. And they are constantly looking for ways to protect and improve that security. And where essentially this happens is most of the applications, the enterprises specifically, they are not reliant on their homegrown application. They are reliant on third-party application that they deploy in their AWS ecosystem and other SaaS applications that they constantly conversate with, because that's essentially where they are looking at the business growth prospect. But with this, especially the SaaS and the COTS application, the enterprises have very minimal visibility onto the security, the performance, and the behavior. At the same time, they cannot fully rely on those third-party applications to have the fullest ownership, because at the end of the day, these enterprises are accountable and responsible for the end-to-end transaction. So they are looking at security applications and platforms like Calico to provide that app-level security, just not on the homegrown, but also on the application that is within their preview, but where they do not have the complete visibility. And this is where the aspects like vulnerability scan and the network level security become so very important. So that way they ensure that they are able to put the guardrails on all these third-party applications that constantly communicate with their enterprise ecosystem. One, to ensure that they are cost optimized, because the performance could result in more cost. And the second thing, also enable the security at the optimal performance. They do not want the security to be another layer that slows down the performance, but kind of provide that security without compromising on the cost and performance. That's essentially where most of my customers are currently focusing on. Because as Dheeraj indicated, a couple of years back, Kubernetes adoption was a big deal. And then over the last few years, it's all been about migrating to the cloud ecosystem, really going with the multi-organization and the multi-region adoption. Now it's all about optimizing the performance and securing, as almost all enterprises are now operating on the EKS ecosystem. That's where most of the attention and focus for the enterprise customers are looking at.
Yes, spot on, Gokul. I will say, yep, that is so true. Look out for all these outside type of attacks which are going to come in, and have as many guardrails as possible at every service level. Yep.
Alrighty. And Diraj, we did get one question, and you kind of responded to them in chat. I was curious if you wanted to bring that on the video about the IPv6 or IPv6.
Yeah, I think so. It's IPv6. I'll have to check for the answer, but the participant 926, thank you so much for using us for eBPF and IP tables. Yeah, and there is a lot of customers of ours which are using us with eBPF quite a bit also. So as you know, Calico works with eBPF, IP tables, Windows. So if you have a heterogeneous environment running, or will have a heterogeneous environment, Calico will work with all type of containers out there, all type of data planes.
Awesome. Very good. So to our audience, kind of last call for questions. I'm going to go through a little bit of our closing housekeeping and start closing us down. But if you do have any more questions, this is our official last call. Josh, did you have something?
No, I think so. Thank you for staying and sticking with us for such a long time. Thank you so much. It has been pleasure talking, and I will say most best thing is like seeing all these questions and answering those questions. Participation makes it the best thing ever. Let me put it this way. Yeah.
Absolutely. So just a reminder to our audience that this session is recorded, was being recorded, and so you will be receiving an email with a link to access the recording on demand. Of course, you can find it living on the Security Boulevard website at securityboulevard.com/webinars. And we will also be hosting it on Cloud Native Now at cloudnativenow.com/webinars. On both websites, make sure to check the on-demand section where you'll find it waiting for you. The 4 winners of our $25 Amazon gift card drawing, they are Adelina A, Arvin S, Tal F, and Paris A. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. It should make its way to you in the next 48 hours. If you don't happen to see that email, check your spam folder just in case it happens to be filtered out. I'd like to thank AWS and Tigera for sponsoring our program today. And to everyone who attended, whether you are here the whole time or just for part of the time, sent in questions. Thank you all so much for your participation. It really makes a program whenever we've got full participation and lots of engagement everywhere. So I really appreciate you being here. And I do want you to stick around for just one more minute. I've got a link pinned to the top of the chat, but if you just stick around, you will be funneled into our webinar survey. We do want to hear your thoughts about this program, or if, of course, you have any suggestions for an upcoming program, we would love to hear your thoughts there as well. Either way, we do hope to see everyone at a future Techstrong learning experience. Dheeraj, Gokul, it looks like we have exhausted our questions. You guys ready to shut it down?
Yeah, I think the 1 hour is good.
Awesome.
Thank you,
Awesome.
Thanks, Neeraj.
Thank you.
Of course.
Thank you, guys.
Thanks for being here, everyone. You may now disconnect.